Good morning to everyone tuning in live from the East Coast of the US, and good day to everyone around the world, no matter what time zone you're in. My name is Josh Epstein. I'm the Chief Marketing Officer here at Aris, and it's my pleasure to be moderating this panel discussion today. So this is part of a series we call Pulling the Digital Thread, where we explore trending topics and technologies that are shaping digital engineering, digital manufacturing, product lifecycle management, really the broader digital enterprise, all from the perspective of a connected data and information framework that we call the digital thread, or that makes up this notion of a digital thread. So our goal is to bring folks from around the world, leading thinkers on the different subjects, and exchange ideas and have a little fun. So we are streaming on a bit of a delay today so that we can get good quality. So please, we won't take live questions, but if you want to participate online, on LinkedIn, please just use the hashtag pulling the digital thread in your posts, and feel free to leave comments, ask questions. And I know all of our panelists here today are active online, and we can keep the discussion going. So this discussion is all recorded, so will be available after the event on demand. So digging in. So today is a really cool topic. I'm excited about it. We're talking about the subject of managing engineering and product design requirements in this age of digital engineering and AI-enhanced product design. So it's not really a reach to think about how the digital thread, can and should extend into requirements management, but we're going to take a deep dive into how the thread thinking can really have a transformational impact in the way that product teams become more agile, the way they become more responsive, the way they bring new innovation to market, and really just the way that they interact with AI and kind of get their job done. So we've got really 4 excellent speakers today. As often, I have my colleague at Aris, Rob McAvaney, the CTO of Aris. Also thrilled to have joining Mike Arnold, the VP of Product Management and Technology with Acuris, Nico Vegerle. Did I say that right, Nico?
Yes.
Vegerle from Certivity, and Rick Razor is the co-CEO of AI Marketplace. Thanks, Rick, for the hoodie. Welcome, gentlemen. Just to start out, let's kick off with a brief round of introductions. Maybe talk a little bit about yourself, about your background, the companies you represent, and maybe spend just a minute, clarifying like what portion of this requirements universe are you really interested in or focused on in your day job. So Mike, why don't we start with you?
Yeah, thanks, Josh. Like you said, I'm Vice President of Product and Technology at Acuris. We're best known as the standards aggregator and distributor, but people don't really know us as a technology company, which we are. And we've been focused recently on the extraction, enrichment, and integration of requirements into those engineering workflows like we're here to talk about today. I've been in what I like to call reg tech or regulation technology for the last 12 years or so, really focus on how do we take things like standards and regulations and integrate those into customers' workflows. And now at Acuris, really focus in the aerospace, oil and gas, automotive industries, and integrating that technology into helping them design their products. Happy to be here, and thanks for inviting me.
Awesome to have you here. Nico, please go ahead.
All right, thanks, Josh. So yeah, I'm Nico. I'm one of the co-founder and the CEO of a company called Certivity. I might be a little bit the alien in the room because I'm like, from a background perspective, I'm a legal counsel, but I worked in the last 8 years actually at this intersection between laws and regulations and the engineering domain, since I was advising autonomous driving companies actually in the way how they should build and deploy autonomous vehicles, which was a quite interesting part. And back in the days at my jobs, I realized that actually like this ever-changing environments of laws and regulations, standards, like everything that is actually on the, let's say, legal obligation side, and like what the engineers needs to do with that, it's pretty much disconnected, since the one thing is paper-based, the other thing is like already, as you said, in the digital thread. And in the mediary step, usually there's a kind of an Excel tool or whatever. But the problem is that it's completely disconnected. And that's actually what we started like 3 years ago at Certivity. We said that we want to bring these two worlds together in a digital way. And that's basically what Certivity is doing. So we're pretty much scraping, crawling, analyzing laws and regulations in almost 50 countries already around the globe for different markets, different domains. We started in the automotive domain to get, but we are like also in rail, like oil and gas is also some topic that is interesting for us at the moment. What we are doing is we are transferring basically this regulatory information into a graph knowledge model, and this can be then connected with the engineering like requirements engineering tools or like the digital thread to stay basically in sync and to directly measure the impact of a regulatory change to a already in development product, let's say it like that. And that's what we are doing at
Awesome.
Certificate.
Awesome. Yeah, well, thank you for being here. Well, definitely, I'm going to, for both you and Mike, I have a whole bunch of questions already I'd like to delve into. But first, Rick, thank you for being back on this series. It's good to see you. Tell us a little bit about what you're up to.
Yeah, thanks for having me. I was a researcher for a while at the Fraunhofer Institute in Germany, and I held various positions there. I was head of digital engineering group, and therefore I worked intensively with companies on topics like PLN, MBSE, and also AI in engineering. And this is where I stuck. So I'm currently co-CEO of a startup called AI Marketplace, and we help companies at the end of the day to find, build, and operate AI applications and product development. I'm totally fascinated by how we can support requirements management with AI, not just automating the test, but also bringing more, let's say, clarity and structure to complex requirements sets. And because I'm background in systems engineering, I'm also very interested in how organizations can move from document centric to truly model-based approaches, right? So I think it's not just for consistency and reuse, but also to make requirements more, let's say, alive and connected to the engineering workflows.
Excellent. Likewise, a whole bunch of questions. But Rob, tell us a little bit about yourself for those that don't know you.
Sure. Rob Backavany, CTO at Eris. I've been with Eris for more than 20 years now, really focused on building up our technology stack and expanding the reach of PLM and the digital thread in industry. I spent my entire career in PLM, so really deep into the depths of how to connect different disciplines across the product lifecycle, I found that, of course, all the different disciplines across all the many folks that are involved with product development and manufacture and service, requirements come from everywhere. And so they're a really critical part of the digital thread. I started my career in the aerospace and defense industry, where there was a really formal methodology behind how you manage requirements and systems engineering artifacts. So I got that bug early about how important requirements are, but that's really helped to shape how we treat it here at Eris. So today, my role is primarily focused on digital thread innovation and how we bring requirements and other elements of the digital thread into the future, leveraging new technologies, AI, and other ways of or other new and exciting approaches to bringing the digital thread together.
Excellent. So let's dig in here, and as usual, Rob, I'll first direct my first question to you, but then invite the team to kind of jump in. I've heard you use the term in the past, requirements as a service, and talk about that. And you've given examples of both what it is, and then if you had requirements as a service, what you could do. But could you just expand on this idea, kind of how you think about it, and really connect to the notion of a digital thread?
Sure. So I think what we've seen, I imagine what most people are seeing is that there are more requirements than ever coming from more sources than ever. right? And while I know a lot of companies in the past have tried to standardize on one single tool that will manage all the requirements, the reality is that's just not possible. It's very difficult to get folks from, for example, the software engineering group to use the same requirements management tool as somebody in systems engineering or in service or manufacturing. So there's many tools that are generally involved, and they're coming from many different angles, right? So different phases of the product lifecycle. They're coming from regulatory bodies. They're coming from standards. They're coming from supply chain. So we find that the requirements are coming from all over, and there's differences in the way they're formatted. So requirements don't come by nature, don't always come with standardized language, don't always come with the model-based approach that Rick was talking about. And we see that, no matter where the requirements are coming from, you see when they are applied to different designs or different types of engineering work, you have flow down and decomposition happening in several different places. Even if a requirement came from a regulatory body, for example, there's decomposition that has to happen in order to apply to individual components or processes, for example. So, but what brings all this together is when I, as an engineer, am doing work on a design or on a manufacturing process, for example, I need access to all the requirements that are applicable to me in one place at one time. And the only realistic way to achieve that, acknowledging that requirements are coming from many sources, is to treat requirements as a service, to be able to aggregate requirements from many different places, get them into some common and certified, authenticated type of format, and put them all in front of me in a way that I can consume those requirements effectively. So we should also acknowledge that requirements are both coming from internal sources and external sources. As I'm sure we'll see today, we'll talk about today, there are new types of requirements coming from curated libraries or of online sources of requirements that can be used directly and can evolve themselves over time. So we're not just talking about requirements that are written into a Word document or are consumed from a PDF externally. We can actually take those requirements directly from external sources and link them directly and maintain traceability to those requirements as they exist on the cloud. So all this kind of comes together to form this concept of authenticated, certified, and common formatted or model-based requirements coming from many different places and delivered to the engineer where they need it, when they need it.
That's cool. Maybe we can come back to this notion of sort of standardization of formats or standardization of presentation views. I'm curious how feasible that is, and kind of how different text requirements. Let's maybe first delve into the sort of, we have two experts on kind of on a separate class of requirements. Maybe Mike, can you talk a little bit about thread connected standards and kind of the standards and regulations that you work with, and really how your customers are leveraging this, and yeah, feel free to sort of comments on what Rob had talked about as well.
Yeah, I was trying to take notes as Rob was talking, because a lot of interesting points there, right? So at Accurs, we talked about standards, and we have a lot of technical data, whether it's regulations, standards, patents, things like that. And all of that comes within an unstructured format. So customers are often used to reading things in PDF, Word document, right? We're humans. We read in human readable language. The problem is all those systems that the engineers work in and where that digital thread is actually connected eventually is all machine readable. So at Accurs, what we're doing is working with our customers to derive that value of how do we bridge that gap between the natural language and the machine language, right? So if you think about standards, and I think a lot of our data partners would agree on this, they're a little bit behind on the technology. They still deliver that standard within a PDF format. Now, there's some of our partners that are moving towards more advanced ways, whether it's XML or JSON or et cetera. But what we have to do at Accurus is really transform that unstructured data into a semi-structured format. We also then take that information and extract the requirements from that in a scalable way. The reason being is that our customers see value in about three main ways. One, faster requirements integration. Currently, engineers take up a standard, and believe it or not, in a lot of customer conversations I've had, they take a highlighter and they go through that standard with a highlighter and find all the important information that they need. And then they're either rekeying and retyping that into the PLM, ALM, or requirements management system, or what they're doing is they're in like Adobe Acrobat and they're cutting and pasting that text into the PLM system. Now, the problem with that is, number one, it takes a lot of time and effort to do that manually. Two, it increases a lot of risk because we're all humans and we mistype, we miskey things into those systems. And then third, as soon as we cut and paste or we retype, they're breaking the attribution and the traceability back to that source document. So what happens when that original document changes? They have to go look in 100 different places to see where they use that information, and often they miss places, right? So that goes to the second piece of value that our customers get from this is traceability and compliance confidence. How do I know that when something changes downstream, I've taken care of everything that I need to take care of and that I've reacted to everything that needs to be touched? And then third, following the traceability, is the change management and the impact analysis, right? So now that I know everything that's changed, how can I actually determine what the impact is? And so along with the requirements extraction identification, we focus on doing things like similarity analysis, contradictions, right? Has something changed? Is it actually a substantial change that I need to react to? And how do we translate that across all of these systems? And so when we talk about formats or standards or things like that, we've really focused on OSLC, which is the Open Services for Lifecycle Collaboration, because a lot of the PLM and ALM systems adhere to that. And as long as our data that we extract is compatible from an OSLC perspective, it creates that traceability, that connectivity into all the other systems, right? I really like, Rob, you said everyone's trying to be that one solution. Well, at Accurus, we don't really want to be that one solution because there isn't just one solution for anybody to come to. And like you said, there's multiple different data sources that need to connect into this overall ecosystem that our customers are working in. So whether they're in Doors or Windchill, Codebeamer, Polarian, whatever, we want to be able to interact with that to take that standards information or requirements, regulations, whatever it is, and provide that change management traceability. And that's why that OSLC is really important at this point in time, where we see the biggest adoption across the board for that type of integration.
That's awesome. And I'm going to save my questions because I guess, Nico, I'd love to hear your perspective. In the types of regulations that you're working with. How do you think about the same question? How do you think about exposing it? And how do your customers actually interact with the data?
Yeah, I mean, I just can highlight like everything what's said before by Rob and by Mike. It's basically the problem of the unstructured data. It's the same with the legislator. I mean, like what we discovered, there are already well advanced legislators. For instance, in the US, like sometimes data is already in a quite digital format, or in the European Union, but there are legislators around the world which have super important markets. For instance, like India, Brazil, Chile, or even China. They are really lagging behind actually, and this data is completely unstructured. Sometimes, like from an input perspective, really scattered. And it's actually quite a challenge to identify in these different regions, basically, where is my regulatory source that I can trust? Because that's also something that we observed. For instance, in the United States, everybody would think, oh, well, okay, the Code of Federal Regulations, that's a trustful source. It's not. It's written there in the disclaimer, actually, the data on the Code of Federal Regulations, or the ECFR, it's not legal binding. What you need to do, you need to go in the Federal Register and take the data from there. So this is the stuff that actually is interesting and challenging, like from a data source perspective, and that's actually what we are solving. So we are like have lawyers and experts actually that really analyze each and every market in detail to find the trustful source of the regulatory information. And then we apply the same thing that Mike basically said. Like we have a structured process where we can parse XML, JSON, Word files, PDF files into a structured format where we break everything into snippets and pieces. We connect that inside of a knowledge graph. And we have developed some algorithms to connect like documents that were changed inside of this knowledge graph to really have the traceability from two different regulatory documents. So if one paragraph is changed, like that you directly have the trace inside of the graph. And basically this data, you can connect with different elements actually with the target systems. You can connect it via OSLC, but you can also do it via RecIF exchange that like you can import it in a structured way. And if something changed, you can connect also based on the knowledge graph, the change in the RecIF, and then you can also update that and just touch the elements that are really touched by a regulatory change or like a document change. But like in my opinion, the fundament is actually to getting data right. And the biggest problem is the scattered like landscape where you find the data, different sources to get it in a unified format. And that's basically what our clients are value the most, I would say, to really get one data format in their target system. And then like if you have the data, you can do structured analysis. For instance, like what we are doing is we can also tell if you are certified, for instance, a product according to like the European regulation. But you want to move to India. So we can do a structured comparison analysis between one regulatory region and the other regulatory region and can directly tell, okay, that's the difference. So you need to basically change this requirement, or it has an impact on that requirement. So that's basically like what we think it's the solution actually to solve the problem and to make everything more connected.
So I'm super curious. Maybe I'll ask this now, I don't know a lot about the standards. I don't know about OSLC or RecIF, but by imposing kind of those standards, first of all, are those, I know they're standards, I know they're very popular. I guess does that still provide enough flexibility in the use case? I'm just curious in general, like, because clearly the way you're exposing this, you're imposing a structure on this unstructured information, and that's really good. That makes it easy to query and kind of look at it and compare and treat it as structured data. But does it bring any limitations, or is it widely accepted this is the direction it's going in? I'm just curious if this is like the everyone agrees that this is the way of the future. It's we're gonna adhere to one or two standards, or is it more Wild West than in reality?
Mike,
Go first, I guess. On our side, I think we see OSLC and RecIF as kind of the two paths forward, right? RecIF just being an expansion upon XML. And that's what most customers ask for, right? Do you have it in RecIF format? The idea, though, when we get from the unstructured to the structured or semi-structured, we can provide it in multiple different formats. And so flexibility is really key, whether it's JSON, like I said, XML, RecIF, even CSV, because different customers are in different points in their maturity, right? We talk about, Rick, you talked about model-based systems engineering. I'd say that's the far extreme where customers are the most advanced today and say, hey, we need this information in this specific format integrated with these specific systems, right? You have your customers that are in the systems engineering bucket. They're not quite to the MBSE, they're not quite to the digitally advanced, but they need that in that semi-structured, structured data. They're still working in documents, but need that connectivity a little bit. And then you've got your, I'll call it your old school engineers, right? And they're like, give it to me in CSV, and I'm working in SharePoint, and I'm doing, X, Y, and Z that way. And so I think the flexibility is key. Mm-hmm. I think the other challenge that we see, at least on the standard side, is there's multiple initiatives going on within industry. We have things like ISO Smart. We have certain SDOs looking at how do you create a digitally enabled standard. This starts to add complexity because now you have different groups working on a quote unquote standard approach to what you're calling, what you say, Josh, right? And when you have multiple standard approaches, you become very unstandardized very quickly. And so at Accurus, what we're focused on is kind of spearheading that to the application of the data for standardization to flow behind. right? And the framework that we've created is flexible, that we can adapt to whatever standard format that is in the future to start communicating with customers. But the big gap is as technology has been advancing so quickly, it's very hard to standardize what that format needs to be, or what a quote unquote digital standard, enablement means. And so we're really focused on providing value first and getting the solution out there and saying, hey, here's the integration, and then let's have standardization come from behind, and then basically standardize that approach moving forward.
Yeah, probably in addition to that, like what we observed is, I totally agree like what Mike said, but there's also like standardization ongoing to standardize digital standards. It's this 5 steps actually of standardized digitized standards. And I recently also heard that like the Dean, the German Institute of Standardization, actually also issued a standard actually how to transport basically the content into like regulatory or standardization content into a RecIF, like what elements, what attributes should be there. So there is a standardization activity ongoing. However, I think like from our perspective at Certivity, we are pretty flexible in our data model, since we are having a graph, and a graph can be like adapted left and right, and like you can add and like change data. So that's the reason why like for us it's key to be flexible. Yeah, and I just can add on that.
Yeah, I want to come back to the graph database and kind of what you might do. But Rick, maybe just to bring in, I'm curious how you see engineers really leveraging all this data, and I'm particularly interested, in you work around bringing AI into the design process, or AI into the PLM process in general, and obviously AI likes standards. Well, I would say that I think it's a safety net, right, to kind of give AI a set of say a semantic layer, or sort of some definitions of how to think about these standards, because it doesn't need it, and it'll go make it its own up. But I'm curious how you think about AI plugging to this, as well as just good old plain old human intelligence in the form of engineers interacting with this data.
Yeah, sure. And I think this topic also touches really on what's said previously. I think this structured format is really crucial for all of this, right? To bring it into a model, right? Because if you then have, let's say, thread-connected requirements, you have really unleashed the power, right? You go just beyond documents, right? You can, especially when it comes to time to market, right? If you're being able to trace, let's say, the change of a single stakeholder change throughout all technical specifications, right? Through test cases, simulations, right? Then I think this is going to be a game changer, and this does not work if we does not have structured data and all of this in kind of a data model, right? So, and I think especially when it comes to complex systems, do it manually, it's resource intensive, right? And as you mentioned, Josh, I think this is also the point where AI comes in. I think Mike, Nico, you already mentioned there are a lot of touch points. You use it, right? Transforming document into machine readable format, so to say, RecIF or standard like that. But you can also use LLMs so to support better requirement formulation. And this is a place where we does not speak about till now, the content, right? So I think it's always good if you have different sources all in the same or different kind of machine readable formats, if it is JSON, XML, RecIF, something like that. But at the end of the day, what's inside it does not have to match perfectly, right? There is, I'm pretty sure, a different data model, what comes out your tools, for example, right? Or if you have requirements based on standards or regulations that are totally different than internally written documents, rather than the documents that you get from an OEM, right? And to handle all this, I think mapping complexity inside, AI can just help, right? To build a parser to suggest the requirements engineer how to map X on Y and something like that, right? Because maybe it's even just a different kind of naming. Somebody calls it functional, somebody else calls it functional requirement, the third one called it FR, right? But all of these have to bring into one thing that can help at the end of the day the user, right? And I think if we do this, then at the end of the day, we can give really systems that help the user. And instead of starting from scratch, an engineer could get a, let's call it, pre-filtered, AI-curated context that's showing at the end of the day what's really affected, how similar changes are managed in the past, and what ripple effects then would be affected in the future, right? And these are the, I think, really exciting things that we see using AI in this whole field of requirements management now.
Yeah, no, it's fascinating. Rob, I'm curious how merging these. I mean, in my mind, there's this universe of requirements, and I think we're talking about standards and regulation, which I guess I'm going to say like there's a truth there. There's really only one way to interpret a standard, one way to interpret a I think one right way to interpret a regulation. So it's conceivable you can kind of, I think, like document it in a standard structure. First of all, I guess the question is that true, but also I assume there's other data sources out there, customer feedback, right? Where there's not a structured requirement. There's more of an interpretation. So I'm curious how you bring all this together in one universe you can work with.
Yeah, for me, I also have to come at this from a data perspective. We talk about standards like RecIF and OSLC, and they're very different things, right? OSLC is a linked data standard to keep data in place and be able to access it from remotely or to link the data while it stays in place. Where RecIF is more of an interchange format where we are standardizing the content of the requirement in a particular way. So if we step back and look,
do they? I'm sorry, Robin. Did they interact? I mean, can you deploy both standards at the same time? I guess.
Conceptually, yes, but they're almost orthogonal, right?
Okay.
One's the content of the regulation itself, and the other is how you get to that regulation, right? So, or that requirement, I should say. So there's a lot going on here, and we need, from my perspective, you need to look at it from a data perspective as much as anything else, because what's important, it's not only important to have access and know that a requirement is applicable to the design I'm working on. I also need to know when that requirement changes, or when the regulation or standard changes, and how that flows down, how that affects what's the impact of a change in how my design is deployed, right? So there's a lot going on here, and AI can help us absolutely, both in coming to standards in terms of analyzing the impact, and in terms of making things that are machine readable, which is, I think, the ultimate goal that everybody shares here, making things that are machine readable easier for humans to consume as well. Right, so all these things come together to in this soup, I guess, to get to the utopia that we're all seeking, which is a completely interconnected, standardized, and event-driven way of managing requirements.
Very cool. Rick, you brought up the LLM term and obviously all the potential touch points where LLM-based AI can really help. I know, Nico, can maybe talk about maybe the process of, you talked about how you extract the intelligence, put it into a knowledge graph. I'm just curious, can you talk a little bit about how you actually do that, what the process is for extracting and structuring, and to your point, what the value of having all this data all this information in a knowledge graph, and other ways that people might consume or interact with that information besides just reading, a set of, standardized, structured requirements.
All right, like how many time we have? This is going to be like a long history session. No, actually, like I try to keep it short, but actually we are using like a sequence of multiple AIs. I would not call it agentic system, since it's not fully automated in an agentic system, but actually like we follow multiple steps. The first step is actually like identifying document, that's for sure. Like let's assume we have that done. But then actually go inside of a document, and then each and every document is different. Like an ISO standard looks different than actually a requirement document from a customer, or like a United States regulation or a European regulation. The first thing that our system is doing is it analyzes basically the structure, like what type of identifier are used, like how is the hierarchical structure, because that like are visual information that we can get out of the context, but actually a machine needs to have that information, like if something is a sibling or a parent from another element. And that's basically like what the first system is doing. They analyze basically the hierarchical structure. And we use a machine learning model for that. The second step is that we are like chunking it according to like basically the hierarchy and like the way how the legislator drafted the regulation or the standard. And then you have like this single chunks of text actually nicely aligned with parent-child relationships or sibling relationships. So that actually represents the document like in a machine-readable format. And based on that information, we have a third layer of information extraction where we then even go inside of each and every snippet and define basically if it's a requirement, a test requirement, or like a certification procedure. On top of that, we iterate multiple times basically over the document to identify, for instance, which is super important later on if you want to write really nice requirements. For instance, the deep links. This is something that actually is sometimes widely forgotten in this discussion, but actually this is a crucial point because a lot of requirements say, hey, please fulfill also requirements of paragraph 5.1, or it references a specific chapter in an ISO document or whatever. And like, if you really want to extract knowledge and make the life of the engineer really easier, you need to take that into consideration and you need to build up these connections. And that's basically another layer of our extraction algorithm where it takes it into consideration and finds the other endpoints in the graph and links it to each other in order if you query for something, you find all the context. For me, at the end, like why we are going in this direction of this kind of complex structured knowledge is actually in case of for instance, using an LLM, what Rick said, for writing a requirement or writing a test case, to get the LLM the best context at the time of the retrieval to write inside of that context. So that's for me like the most important thing, and like everything that adds on top of that context, what you can do before in the processing will drastically increase the quality that you have at the end, like as a requirement or test case, what is formulated by an LLM. That's basically a little bit how we are doing it. Like there are a few more steps where we analyze basically the content, like from a regulatory perspective, to get like subject matters out, so to understand what is regulated, to apply it. So for instance, for different products, one like major example, what is really difficult to understand, for instance, you have a general cybersecurity regulation. It's a generic regulation that applies for all products. And then basically to understand that, like if you build a connected fridge, you need to apply like this generic cybersecurity standard from the European Union or from wherever, because like in the regulation, nothing tells you that a connected fridge falls under this regulation. It's implied, that's a connected like knowledge that you need to connect. And that's basically like what we are also extracting to really go inside of a regulation or inside of the content and try to find what is regulated. And in this case, the cybersecurity of products. And then basically later on, if a customer asks for, hey, what I need to comply with for my connected fridge, then we can go and like based on the context, we can tell, hey, it's this cybersecurity regulation in the EU, but it's also this eco guideline in China, because like we can draw the context, and that's a difficult one. That's by far most at the moment like our most difficult problem to solve.
Yeah,
but yeah, we are progressing.
No, that's I want to Rob. I want to ask you like. From the perspective of architecting a digital thread strategy, right? And this would be, I think, great example of how complex or how rich the ecosystem of data or information that you're just generating just within your kind of domain of requirements. Rob, I'm thinking like how, as people are looking ahead to the future, right? And they want to lay a foundation from a data perspective, from a digital thread perspective, how should they be thinking about, constructing it so that they can interact with Certivity, with Accurus, with product engineers with whatever's with customer feedback information? How do you think about that structure?
Yeah, I think the most important thing is to value open connectivity and understand that these things are going to be coming from multiple sources, probably with multiple formats and different data paths to get in front of the user that actually needs to understand the requirement. So when you're looking at building your digital thread, you have to start with the assumption that that the data is coming from heterogeneous sources, that you need to provide a mechanism to consolidate those sources and provide a viewpoint for the user that makes sense in their context. And I would also think we need to acknowledge that the requirements are always going to evolve, and that we need to have an acknowledgement that the data is not static, and that a change upstream can have a significant impact. So the focus should be on open connectivity, change management, impact analysis, all the same kinds of things that we talk about for other parts of the digital thread, but probably hitting us sooner in the regulation space or in the requirement space because of the work that companies like Certivity and Accurus are doing to make these things more accessible and openly, such that they can be consumed into the digital thread directly.
Yep. Mike, you had mentioned, it sounds like Accurus is extremely flexible in the way they're actually delivering your service to your customers. I guess, do you have like a best practice though, or do you have like, if the ideal scenario for a engineering organization to take full advantage of the dynamic nature of your data sources, is there like a best practice, or how would you guide, or how would the most forward-looking teams interact with Accurus data?
Yeah, I think our main customers who extract the value from our platform and from the data are the engineers, right? But the teams that we really work with are on the technical side. That's the integrations and who's consuming the data and getting it to those engineers. And for us, it's all around like the strategic partners. So, let's say like at Eris, you guys don't want to go and have to sign 450 different, contracts with SDOs and aggregate this data and get this consumed, right? Mm-hmm. That's just not part of your strategy. Well, we can come in and help in that area, fill in that gap, and then start to provide that information, right? Mm-hmm. I think what we see in industry is some of the companies that want to be the end all be all, they become very heavy solutions. It's hard to integrate with. They become closed ecosystems to keep that in, and customers don't like that, right? To Rob's point, this open kind of ecosystem that we have, this interactions and data passing between each other is super important. And so we're API first on everything. Well, we have our UI to facilitate certain workflows that our customers use our data and consume our data in, and ultimately get it into a way, shape, or form to extract. We also provide all of our services, like our decomposition services, our requirement extraction services, enrichment services via API. Mm-hmm. And so if they do have another system, we're flexible enough to fit into that. And we have our professional services teams and our engineers and architects there to support those types of integrations. And so, whether it's, Rob, I really liked your definition between, the RecIF use case and the OSLC versus linked data and actually getting the text in there. It really depends on what you're trying to accomplish as a company. Mm-hmm. And so really understanding what you're trying to accomplish and what the end goal is going to lead you to how you're going to adopt that technology. For us, OSLC is really important because we have data partners that are very protective of their information. They don't necessarily want it leaving the Accurus platform and kind of disappearing into the ether of a PLM or ALM system. So in that case, OSLC is very useful because it creates that link, provides the change management into those PLM and ALM systems while maintaining the source of truth and that data within the Accurus platform, right? Some of our partners are more comfortable with like the XML RecIF, where, okay, the full text can be extracted and then taken and still create that traceability and link into the PLM ALM system. It's just two different ways to accomplish, similar things towards the end of the day. So I think when we work with customers, we really focus on the use case and what's the problem trying to solve, and then let the technology come in after instead of leading with the technology. And I think that's where we always get caught up. And a lot, recently, LLMs super powerful, but in a lot of conversations, the first thing a customer says, or other people say, is like, "So what are you doing with LLMs?" It's like, well, what are you trying to solve with that LLM, right? Let's start there, because often, I don't need like a house-sized boulder to nail a nail in, right? I just need a hammer. So what's my hammer here, and how can we get you the best solution possible?
Excellent. No, and Rick, I'd love to turn to you, and I can almost predict what your answer is going to be. It depends, but from the perspective of building applications, AI-enabled applications that support engineering, across the board, can you talk a little bit about how you think about that? How the ideal approach to exposing data? And I know you're going to say it depends, so you should just start out with that. But to maybe kind of give us some examples of different types of AI-enabled engineering applications, and really how they would want to be interacting with requirements data.
Yeah, sure. I think this also fits what Mike said, right? So first of all, let me say, I think AI and requirements engineering is not entirely new just because now we have LLMs, right? Even before LLMs, there were a lot of efforts using, let's say, classical data science or classical AI pipelines, and feature engineering. All stuff were already there, right? I think what's now new is how accessible things have become with LLMs, right? So today, if you build AI-powered requirements management support, you can do it with prompt engineering or simpler API scripts, right? And where you before needed, I think, weeks or months of development, right? And best case, if you combine everything like Nico said, right, in a pipeline. But the ease of access also raises to these concerns I think you want to highlight, Josh, right? Because people are afraid that sensitive data is put into, let's say, public or available SaaS chatbots, right? And people don't want to see that, right? I think luckily a lot of companies today have developed the first policy in how to use these chatbots. But when you really build an RE application that integrates AI, I think a right foundation also should be to make it PLM based, because these systems already have like user and role-based access controls, right? You can use traceability things, you can make lifecycle control, right? And building on top of that, you can really define what kind of, let's say, data processing is allowed, right? And also you can track, for example, what model was used by WOM, what output was generated. So all of this can already be achieved, right? And I think then, depending on the, let's say, criticality of your data, you might have to decide at the end of the day from the infrastructure layer how to run a model, right? On-prem for very critical data, within a private cloud or trusted hyperscaler, right? But let's say, to sum up, I think the AI integration may be achieved more easily today. And if you use the data governance that is maybe already there in tools like ours, I think it's a perfect match, so to say.
Thanks. I guess, yeah, maybe just time for some last thoughts. Rob, you've heard all this. Like, how would you wrap this up? How would you sort of, now that we all know about the offerings from Certivity, from Accurus, we sort of expanded the audience's mind about kind of this requirements. How do you get started here? How do you make progress?
Yeah, I think it depends on where you are to start with. Obviously, most companies I run across have multiple tools to solve multiple problems. So I think you should approach the problem strategically, step back, find all your sources of requirements, start really thinking about whether that's the future solution for that type of requirement, or if there's something more modern and more forward thinking that you could leverage, and then start build a strategy, build a plan, and then start picking off the different types of use cases that might be able to modernize your approach to requirements. So start small, get time to value as quickly as possible, and work towards an interconnected requirements as a service approach.
Excellent. Mike, last thoughts from you.
I couldn't agree more with Rob. I think, starting with time to value, what's the first, take it in pieces, right? I think the approaches that we've discussed here, whether it's Nico, myself, or Rick, they're all very complementary of each other, even talking about from a regulation standpoint, standards or other technical data, and even leading to an LLM, right? High quality data is of importance across the board here at every step of the way. And if you don't have a strong foundation, you're not going to build, as high as you possibly can. And so really focused on, Rob, to your point, what are we trying to do strategically here? Where's all of our data? What kind of quality are we looking for? What is the application of that, right? It's very different to say I'm building an airplane versus, I'm building, I don't know, like a stapler here on my desk, right? Like the implications of that design and engineering practice are completely different. And so it breeds more risk, right? You need higher quality. And then to the point that when you're comfortable and have that strong foundation, to take advantage of the new technology available today, like LLMs, like different agents to tackle different problems that you're looking at internally and to automate and create those efficiencies. And so, I've just enjoyed listening, to the others on the call as well and hearing the approach. And I think today's been fantastic. And thanks a lot.
Do you really have a stapler on your desk?
I do, sadly.
Really? Swing line?
It's not for me though. It's for my wife. So
okay.
She's a printaholic over here. I got a printer that runs 24/7 and stuff. So.
Awesome. Nico, last word, I guess, for those out there that are just getting their arms around this idea of looking at requirements, looking at regulation in a more systematic way. How do you get started?
I mean, I couldn't agree more. Like, actually, Mike stole the words out of my mouth. I also agree that the foundation is data. If the data is right, if the data quality is high, you can leverage basically the models on top of it, and it doesn't necessarily make a difference if you are working with the latest model of ChatGPT or with Gemini or with this one. Basically, because to get the context and to reason, they are already on a high level, and this will develop over time. But actually, what they are super bad in is actually getting the information out of document and putting that into a context of a complex environment. And that's where this data source or trusted data source is basically the fundament. And yeah, that's my take. That's what we are building. That's what we are focusing on to really build a high quality, trustable data source around the globe for regulations for all products, and that's
awesome.
What you can get.
Awesome. Listen, I want to keep us on time here. We definitely covered a lot of ground. I appreciate everyone is talking as fast as I did. So I even our non-native English speakers were speaking at a high rate. So I think we covered a ton of ground here. I encourage everyone out there to check out Certivity, check out Accurus, check out AI Marketplace, check out Eris. But with that, I'd like to just thank everyone here for taking the time to talk to us, and encourage everyone listening out there to engage on LinkedIn, ask questions either individually or just using that hashtag pulling the digital thread. So with that, thanks everyone, and everyone out there listening, have a great day.